You're listening to the N2K Space Network.
Around every entry point and every clever attacker, Vectra sees the attacks others can't. How? Vectra has AI on it. Vectra's AI attack signal intelligence tells security teams where to focus, what matters. It wades through thousands of individual threat events so you don't have to. Attackers infiltrating your network? Vectra has AI on it. Attackers compromising your identities? Vectra has AI on it. Vectra AI, the integrated signal powering your XDR. Visit vectra.ai/showme to learn more. That's vectra.ai/showme to learn more.
The future is in the skies. Humanity is launching more spacecraft to orbit than ever before, but spacecraft are still limited to the amount of fuel that they are launched with, which limits flexibility and poses long-term risks to the space environment. Is there a better solution? Welcome to T-Minus Deep Space from N2K Networks. I'm Maria Varmazes. Orbit Fab was founded in 2018 to eliminate the single-use spacecraft paradigm with in-space refueling. After proving their concept during their mission to resupply water to the ISS, Orbit Fab later launched the first commercial fuel depot into LEO. Yes, gas stations in space. Who knew? Well, Daniel Faber did.
My name's Daniel Faber. I'm the CEO of Orbit Fab, the gas stations in space company. I've got 25 years experience in the industry, started as an engineer, built a dozen satellites in different countries around the world, and then started building companies. So Orbit Fab is number 4.
That's amazing. I would love to hear about your vision for Orbit Fab, how you came up with this incredible idea. It's very transformative.
Yeah, thanks. So when we sold the last company, that company was building thrusters to move satellites around in orbit. So I had some acquaintance with, selling thrusters to satellite owners, to figuring out how to do the trades on fuel efficiency and all the other parameters. And of course, we'd seen the huge paradigm shift from SpaceX recycling and reusing their rockets. Right, that was massive. And the uptick in number of satellites getting launched as a result of the dropping costs and things has been huge. So I started asking around, what impact would it have if you made the satellites reusable? What would that take? Like, the one consumable on them is fuel. They can use solar power for everything else, but you need fuel. You have to, even to stand still, you need fuel to keep moving back to where you were, because everything drifts. Let alone if you want to actually cooperate, keep things in a coordinated constellation. And the reason there's been no upgrades and maintenance and repair and assembly and what have you is because we haven't had fuel to move. That one tank of fuel you get is so precious. And when it's done, you throw the satellite away. We literally throw away $10 billion worth of satellites everywhere, every year. This is insane, right? This is dumb. But most importantly, not just can we solve a problem that obviously needs to be solved, what is it worth? Right? That was the question I asked. What's the marginal revenue you could get if you had 1 extra kilogram of fuel? And I was blown away when the answer we got, not just once, but again and again and again, was that the marginal revenue was often over $1 million per kilogram. I know the launch companies, we could probably launch for between $1,000 and $10,000 a kilo. That's the biggest input cost here. And the value created is $1 million per kilogram. That's almost 3 orders of magnitude arbitrage. I could probably stick a business in that. So that was it. I dropped everything else. I'm like, I'm canceling everything. I had other ideas. I turned checks down on those. I'm all in now on Orbit Fab. I know these people. I know this market. I know how to sell you it. And now I understand the value. Let's go. That was 6 years ago. And now it's a reality. Now everyone's on board with this new paradigm.
And it's been really amazing watching Orbit Fab growing and all these incredible agreements coming out and new deals. And I just, as somebody who's watching the industry, it makes so much sense. And so I hear it happening. I'm like, yeah, this is awesome to see. I especially, I mentioned a little earlier, we have a lot of interest in what's going on in the UK. You all are doing making a lot of inroads in the UK, especially. Tell me more about that.
Yeah, so we knew that the space industry is very strategic, right? There's a lot of geopolitics that plays into it. And so a lot of the funds come through national governments, often national security, and there's a big imperative to buy local technology, support local industry. So we realized if we wanted to engage with Europe and with that market and help the operators out over there, we likely needed a European or UK presence. So we did a bit of a study of my previous company. We'd set up a subsidiary in Luxembourg, so I'd been through that process, and that was very high on the list, was to go back and work with them. But the UK Space Agency had written a strategy about satellite servicing, and that's really tow trucks, right? Deorbiting and upgrading and everything. You can't run a tow truck without fuel. You tow 2 satellites and then you throw away your shiny new tow truck because you have to go and chase things down. So they were already building into their strategies that the first mission would be active debris removal. The second mission would be a refueling mission to refuel the debris removal, the tow truck. So it made obvious sense. They came to us during IAC in Dubai a few years ago, hunted us down, sat us down and said, what do we have to do to get you over here? And I said, well, money helps, but having gone through, money always helps. Having gone through setting up a subsidiary on the other side of the world before, the biggest lesson learned was I need someone to run it who is going to be a great leader, who's going to be a self-starter, so I don't have to be up at 4 a.m. every day to talk to them, right? I don't have to stay up until midnight to catch them. I need somebody. And so they said, well, we can help with the money side, but that led to other conversations, and I realized Mani Shah was actually going to get interested in it. And we had some conversations with him and ended up bringing him on as our UK managing director. Now, he built the Bryce Tech office up to about 10 people in the UK. He's been at Inmarsat. He was a banker before that. But his background is engineering and computing. So just phenomenal background, phenomenal guy. And that was the crux of it. So the reason we ended up in the UK really is because we found Mani to run it. And he's done a brilliant job. He built it up to about 10 people. And then we hired a fantastic managing director. Jake Gear joined us, leaving the UK Space Agency. And Mani stepped back. He's now our chief strategy officer. But that's allowed us to keep building the team. And recently we had another win. We're now up to 15 people in the UK. It looks like we'll be 20 people, possibly even 25 before the end of this year. So that just keeps growing. We're so glad that we did that. It's been absolutely the right move.
I feel like I should ask, what other markets are y'all thinking about? Can you tell me?
Well, from a geopolitical point of view, like all the Western allies and aligned nations need to have compatible systems in orbit for the national security systems. So all of those countries are interesting to us. The AUKUS countries, so that adds in Australia, which is where I'm from originally, so I'd love to do more there. But also Japan, India, there are other countries that are active in space that are looking at this. So that's a national security side. The commercial side, it's everyone and anyone that we can get to that happen to end up being the same countries, because the national security programs over the years have built that critical mass of expertise, which has then flowed into all of those commercial programs. So again, North America, Europe, Asia, we look for the commercial customers. So we're engaged across the world right now.
That's fantastic. And again, it's so great to watch you all grow. And because I'm in the United States, I'm really interested in what's going on in the United States also. You all have been doing a lot of really good deals in the United States, like Space Force work as well. Tell me a bit about what's been going on there, because it's been, again, really wonderful to see it happening.
Well, let me start with the top, with possibly our most important deal. So Space Force have bought fuel from us for delivery in orbit. And this is the first time that's happened. We'll be delivering fuel in sort of 12 to 18 months' time. So all the hardware is now built to getting shipped for integration and getting ready for launch. And delivering that small of fuel, and it's a small amount of fuel, so they can do demonstrations, they can test, they can build their operations scenarios. We're already seeing them think through how they're going to operate this. Now that they've finally got mobility to the point that they're out of that paradigm where shifting a satellite is just so onerous, right? Think of a national security asset. If you shift it today, you use up some fuel today, you just shorten the life of it. And now when you get to the end of that, if it's 5 years from now or whatever it is, you're now gapped. Because when's your replacement system coming on? Which means a national security capability no longer exists, at least for a period of time. That is a risk. That is terrible. So everything you do is around moving as little possible, is sticking to the schedule. And if you do need to move it, call a 4-star general, right? You've got to understand the implications of that. All of a sudden now we've given them the option. There is an easy button. Just go move your satellite, do what you need to do, prevail, set things up, and then press the button and get refueled. That's what we're offering them. And so they're coming back, having now worked through these concepts and going, we do need more fuel. Let's increase that. So Orbit Fab, we're in a great position now because we can just keep providing that fuel on that existing contract. So that's really been interesting. But it's not just that one's through like Defense Innovation Unit. Well, we've got various branches of DoD, from the R&D side through to the operations side, the training side, the acquisition side. Everybody's sort of lining up and saying, all right, this is needed. This is going to be how we're going to be operating satellites, definitely in geostationary orbit, but also in low Earth orbit, right? So all of that is just really exciting as people shift over to the new paradigm.
Yeah. Speaking of the sort of the new paradigm, talk a little bit about the tech, because I'm so fascinated by the actual tech that you all are making, because to me, it's like you're creating a whole new standard. And that's a very exciting place to be. Maybe a little scary, but also very exciting. Tell me about Rafty. What's going on there?
Yeah, so I get excited about this because this is my business. And I think other people do because it's space. But let's face it, at the end of the day, we're pumping gas, right? That's what we deliver gas. It's a tried and true business model. It's a valuable business model, but it's perhaps not the most exciting business model on Earth. We're just trying to move that business model into space. But the first thing we needed was, like you mentioned, an interface, because no satellites had a gas cap that could be refueled in orbit. They have valves they fill the satellites up with, but then they shut them tight, then they shut another cap on top of that, and then they lock it down with wire, and they're effectively welding the gas cap shut. Imagine buying a car with a welded gasket. That's what everyone's been doing. So we said, well,
why would anyone want to reopen it, right?
Yeah.
Right, yeah.
So that was the first thing we had to do, was figure out, well, can we just build a gas cap and get everyone to use it? Or could we do robotic surgery on the satellite and put fuel into it? And NASA's been trying the OSAM-1 mission to do robotic surgery. And the discovery of that was, it is hard. It is expensive. They spent $1.5 billion trying to get that work. It was going to take another $1 billion to get it going. We decided we'd try the other path, which was to build a gas cap and get everybody to take it, which means we can't refuel the legacy satellites. But what we can do is work with these tow trucks, with these satellite servicing companies. They can take the gas cap. They can go around to all the other satellites and work with them. And when they run out of fuel, come back and get fuel from us. So they could do life extension by attaching and taking over like a jetpack. They can do a bunch of other things. Maybe even someone will figure out the robotic surgery. That's great. We'll resupply them with fuel. And so that was always our assumption. But to get to that point where we could build the tech, we had to figure out what it should be. And we ran into all of the usual problems of product design, where I have a bright idea and my customers don't care how smart it is. They care that it's pink, right? They care about something I hadn't even thought of. And when you get to docking two satellites together in space, turns out that's kind of complicated. And there's a lot of things you haven't thought of unless you've tried to do it before. And
orbital mechanics. Who knew that was complex?
It's not just orbital mechanics. It's the plasma dynamics. It's the thermal, it's the optical environment where you've been in this big void and all of a sudden you've got reflections, right? Everything interacts. Magnetic fields interact. Electrical fields interact in ways that are completely not intuitive. Humanity doesn't have enough experience in this. It's not that the space environment is any weirder than, say, a boat on the surface of the ocean. It's just that we have a lot more experience with boats on the surface of the ocean. And we have to learn all of that now in space. And we've only had 50 years of operating and not really a lot of assets up there, to be honest. So that's what we had to get over. So we just went and did it. We put 2 payloads on the space station and we transferred some water backwards and forwards. We actually offloaded the water into the space station, became the first private company to resupply the space station with water. NASA threw the book at us because, firstly, transferring any fluids on space station is dangerous. If it gets out, you can drown an astronaut. You can't brush the water away because the surface tension will bring it straight back. And you can't yell for help if you're under an inch of water. So that's pretty dangerous. And then we actively pumped the water into the water bus. And if we overpressurize the water bus, it could spring a leak and they might have to evacuate. I can imagine the water going everywhere in space. They don't do that, right? So NASA said this is a catastrophic level hazard. It'll take you 2.5 years to work it out. And we're a startup company, so we did it in 4 months because we had to. We made friends with everybody. We figured out what they meant, what was real, what were the requirements, like what's the safety implications. We solved those. We took the risk that we were getting ahead of it, and we were building the thing before they'd signed off on it. If they'd have said, no, that just won't work, we would have to start again. But we took that risk because we didn't have the choice. And we were able to, we had people on the team who'd launched things to space station. We got ahead of that. And so we were able to build something that would work. And they said, okay, it's safe. Even at the few times where they said, this doesn't follow the letter of our requirement, but it does achieve the intent of the requirement. So they signed a waiver, right? Those are so important. So that's why we did that in 4.5 months, like so much quicker. And I think we broke speed records of getting something up to station, especially something that complex. So then we launched the first fuel depot. And this is a really small minimum viable product. The first time we had our Rafty interface on it, our gas cap, we put that into space. That was a 6-month development program. Again, not intending to actually build anything that would deliver fuel. We're intended to learn at the highest possible velocity. And by having done that, we could go to prospective customers and say, here is Rafty. This is the gas cap. We've flown it in orbit. Therefore, it's got flight heritage. It's TRL 9. Why don't you buy them? And they said, because they suck. And we said, well, why does it suck, right? And they gave us a long list of reasons why it sucked. And they were right.
Not what you want to hear, but yeah, okay.
But we already knew, we already knew it sucked. We'd used it to fuel on the ground. And we were fueling hydrogen peroxide. High purity hydrogen peroxide is dangerous, right? It'll take your head off. You've got to be careful with it. So we had to go through all that safety in the most critical point, which is when there's people around. So we'd found out things we wanted to fix. The customers came back with a list of the same kind of things we'd found and a few more. And within 2 months, we turned around the new design and said, here's your design. Here's something that ticks every single box. And they loved it. We turned the critics into champions. But that's how we built Rafty then to be the best, not only the best in-space refueling valve, we wanted it also to be one of the best docking interfaces and to be the best fill drain valve on the ground to replace those valves they currently use. It's the same size, weight, and cost, so it's a drop-in replacement, making it an absolute no-brainer. The amount of engineering that takes is insane. And the result is something with 6 parts that looks really simple. You would not believe how hard it is to build something simple that has to do such a complex job. That's how we got to Rafty. Now it's flight qualified, it's shipping. The active side, the nozzle, is going through flight qualification. Everything is lined up. So we're now ready to deliver this fuel to the government. We're on contract next year. So super excited.
We'll be right back.
Quick question. Do your end users always, and I mean always without exception, work on company-owned devices and IT-approved apps? I didn't think so. So my next question is, how do you keep your company's data safe when it's sitting on all those unmanaged apps and devices? 1Password has an answer to this question: Extended Access Management. 1Password Extended Access Management helps you secure every sign-in for every app on every device, because it solves the problems traditional IAM and MDM can't touch. And it's now available to companies with Okta and Microsoft Entra, and in beta for Google Workspace customers. Check it out at onepassword.com/cyberwire. That's onepassword.com/cyberwire. The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business.
That is very exciting. And you've mentioned what an incredible engineering challenge that is. This feels like a good time to ask a CEO question about your team, the people that you want to be, who are working at your company and who you're looking to hire. What does it take to be like an excellent member of the Orbit Fab team?
Oh, the first question we ask, what have you built? Right? I love grads who are just coming out of university who could say, well, I built this thing and it didn't work, right? I gave it to somebody else to use and they told me it sucked. Every time you build something and give it to somebody to use, they'll tell you it sucked. Just take that as a given. But to have lived through that process and to have somebody have used your widget in anger, be it some software and for marketing folks, like have you done designs that have actually gone out to the public or something like that? What have you done? Do some extracurricular activities. Those students are more valuable than somebody who's just even got top grades but never got outside the classroom, right? Spent 5 years in industry working on the thing they're given. No, give me someone who's just taken the bull by the horns, right? Decided they want to build something, gone out and done it, and failed 3 times and succeeded half, right? That experience is what we're looking for because we need to move quickly, right? We need to be doing things that are innovative and outside of the box. Now, there's a flip side of that. We're working for the government and there's some national security assets. We've had to get Rafty accepted, and it now has been accepted for use on DoD satellites, which means it has to be reliable. So I've got to take those young, innovative people that haven't learned bad habits yet, people that haven't got stuck on the bureaucracy, and put them together with people that know why the rules exist. They know why flight qualification looks like it does. And that's a challenge. To put those two together is a bit like oil and water, right? Move fast and break things, move slow, make it reliable. Well, how do I move fast and make it reliable? That's the key to putting together this team. And it took us a while to get that team together. Right now, they're crushing it. We delivered, I think, 25% of the things we delivered to customers this year were actually due next year. So getting ahead of that schedule is a testament then. The team is amazing. I couldn't be more proud. I walk in every day and just I'm overawed to work with these people.
I can tell from the way you describe them too. I mean, it sounds like it would be an amazing place to work. I mean, what you all are building right now is already so innovative and way ahead of, I think, where most people even thought we would be. But you've got to have a grand vision that you all are building towards. What can you tell me about that?
You say we're ahead of where we're going to be. 25 years ago, when I was at undergrad, I decided, let's get humans off this rock. This will be the most important thing for humanity, might be the most important thing for life since we crawled out of the oceans, right? Let's do that. It might even happen in my lifetime. I wrote down a list of industries I thought could pay for the first permanent jobs in space. And I decided I'd chip away at asteroid mining because the only other thing on my list was tourism. I've since added entertainment content and manufacturing in orbit. There's a few others. So my list has got longer. That's good. But in first year undergrad, that was it. And I've basically spent my whole career sort of hunting around how to get asteroid mining economic and how to create the bustling in-space economy. So in that context, what we're building with Orbit Fab is the industrial chemicals supply chain. It's the material supply chain in space that has not existed. It starts with fuel. It starts with gas stations in space because that's what people want to buy. But people are also going to want to buy air, water, 3D printer feedstock, minerals to grow plants, construction material, different chemicals for their in-space manufacturing. At some point, we're going to unlock the material in the asteroids because we have a supply chain to take that in. I want Orbit Fab to be the biggest customer of asteroid and moon mine material. We will own the refineries, the storage and the distribution. And I want to do it all to build things in space. We'll probably end up selling some things back to Earth as well, but that's secondary. This is a business that is built to sell things in space, to build and manufacture in space. That's the heart of what Orbit Fab is doing.
Oh, that's amazing. That's amazing. And that vision and that future is coming a lot faster than I thought it would. And I'm so glad to be seeing it happening actively right now. It gets me amped every day when I do this.
Well, you've got to understand, I've been working towards asteroid mining for 25 years. And it is now 25 years closer.
Yeah.
I still don't know when it is.
I know. It's one of those things, you look at plans from decades ago, it's we had this vision all that time ago. It just, stuff takes a while. And, money is not as ample as we would like for many of these things. But yeah.
And that's been the crux of what I learned. I mean, the first dozen years, building satellites as an engineer, I thought that if we just build good tech, people will buy it. Right? I could solve any problem. I had the hubris of a decent engineer. I could solve any problem. This is great. Why don't people just give me the money? Well, I've spent the last half of my career trying to get the money together, and I've realized you've got to serve a need people have. You've got to find a problem that's worth solving, not just go and solve something people don't want to buy. And that's actually a lot harder. So that's the crux now. And I think it's part luck, part hard work, part just industry knowledge, everything else. We are in such a lucky position here with Orbit Fab. We set it up 2 years before Space Force was formed, right? The Air Force didn't even know how to spell satellite surfacing. It wasn't a thing. But as they've realized how critical this is going to be, we've always been a couple of years ahead. And now we're in this just such a lucky position to be in.
Well, I would say a lot of forethought went into that, and luck always helps. But I think you had that vision. And speaking of getting closer to the future, that many of us didn't think was gonna be happening as fast as it is. The chopstick catch is super heavy. So we are getting awfully close to that Starship enabled future that I know we cannot wait for it to happen. Where does Orbit Fab fit in that? Because that day is coming when we're going to be sending stuff up on Super Heavy and Starship. Where does Orbit Fab fit in?
Since day one of the company, we started about the time that Elon announced like Starship is going to come. And so every time we've done sort of what's our strategy? Why do we exist? What are we planning for? We've had to have two worlds, one in which Starship exists and one in which Starship doesn't exist, just in case one of the two will come true. We now seem to be on, frankly, the better one, where Starship exists, which is amazing. And there are other companies out there that'll come in a few years. Like if you haven't got a reusable rocket, your rocket company is dead. Get on with that. The same's going to happen on satellites, right? If you haven't got a reusable satellite, refuelable, serviceable, everything else, your satellite company is going to be eclipsed by the competition that does. So that's been a huge tailwind for us. The other thing that we say, and Starship's it's got so much capacity, 150 tons to low Earth orbit. I love that. And they talk about that flight cadence. If they hit a fraction of that flight cadence, and no one should doubt that they're going to hit a great flight cadence simply because of what they've done with the Falcon 9, right?
Falcon 9.
It's all designed around that. The potential for the cost to come down and the lift mass to go up is going to change just everything, right? Satellites will get bigger. And if you look at what happened with miniaturization, like people started launching CubeSats and said, the future is these miniature things. And everyone who's launching small satellites who found a real market grew their satellites. So the Doves are now Super Doves or SkySats. Starlink is 200 kilos, is now almost a ton. OneWeb, same thing. Every operator used the small satellites to do product market fit testing, to make sure they had a market, to develop that. And once they knew what they had, they could scale it best by increasing the size, economies of scale. And so that's what we start seeing. Starship enables us to massively double down on that. We can now launch satellites bigger than anything we'd even conceived of before. So while the biggest geocomsats are 5 tons, watch out for a geocomsat that's 50 tons. And then look for assembly, where those assets become 5,000 tons. They will double down on economies of aperture scale, right? Sometimes there's just no replacement for having a massive antenna, a massive optical system. Others will go with the massive constellations. But even those satellites are going to get bigger. And we're going to see a combination trend with reusable rockets, the drop in launch costs, the increase in up mass, and Orbit Fab, like the refueling and the servicing things. There's so many companies working on that, the tow trucks. We're going to be able to have cell phone towers and platforms in orbit that we can upgrade. And so when we want to go from 5G to 6G in orbit, you don't have to bulldoze the hill, rebuild the cell phone tower, put in new fiber optic, put in new power lines, build a new power station, and then put your transponders on it. No, you just put your transponders on the existing cell phone tower. That's what we do on Earth, and there are millions of cell phone towers to get global coverage. It's going to happen in space. We're going to just upgrade these platforms, refuel them, maintain them, and put on the new transponders. And we sat down with the chief of supply chain of one of the large mega constellations, and we told him the paradigm, and we gave him our input numbers. I took him that here's what we're charging the government right now for fuel. And he did the math and said, this is going to end up with an order of magnitude lower capex. Rather than spending $5 billion every 5 years to upgrade the constellation, where we've got to design the satellites, build a satellite factory to be able to mass produce these satellites and then get them to orbit with a huge number of rockets, because we're launching whole satellites, right? And they're only getting bigger, right? $5 billion in 5 years. With the upgradable satellites, they could do it for $500 million in 1 year. It's an order of magnitude cheaper and a factor of 5 faster. That will drop the cost of doing telecoms And the telecoms industry is $2.7 trillion. Most of that is going to go through space, right? This is the huge opportunity we have. And of course, every tower in orbit, it's going to drift. You need fuel to keep it in place. You need fuel to keep it coordinated. You need fuel to get out of the way of collisions. You need fuel to run the servicing vehicles that are going to be installing and taking away those old transponders. Orbit Fab is ended up owning the key to this, right? We're creating that critical piece of infrastructure that can get built on. This is what I tell our investors, like, our addressable market right now is $10 billion a year. But as soon as this happens, and as soon as the unit economics are proved out, 3-4 years, this is going to happen. Our market is going to 10x, right? We're sitting on a $100 billion a year market. This is the exciting thing that we're building. That's the future. And you can imagine that bustling in space economy and all those things we build is going to let everything else that happens in space happen on a bigger scale as well. So Starship plus everything in this ecosystem, I think, is going to get humanity to space. We're on the edge of being able to have such a big economy in space that it can support permanent jobs. That's really what I'm pushing for.
That's it for T-Minus Deep Space, brought to you by N2K Cyberwire. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures we deliver the information that keeps you a step ahead in the rapidly changing space industry. T-Minus Deep Space is produced by Alice Carruth. Our associate producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Our executive editor is Brandon Karpf. Simone Petrella is our president. Peter Kilby is our publisher. And I'm your host, Maria Varmazes. Thanks for listening. We'll see you next time.